So when we find the intersection of two functions, we're basically solving the system that those two functions belong to. In chapter 4, we learned 3 different methods of solving systems, and we dealt just with linear equations, so just y equals mx plus b type equations. We're going to use those same methods, except now our system might have a line and a parabola, it might have 2 parabolas, it might be a parabola and some other different function, or a line and some other different function. So we're not restricted to just linear functions. Our 3 methods that we learned were equal values, substitution, and elimination. For these, the easiest one that we're going to be able to, or easiest method that we should use will be the equal values method. Both of these are equal to y. That means they must equal each other. So since y is equal to x squared minus 3x minus 10, and y is equal to negative 2x plus 2, that means those 2 expressions must also equal each other. Okay, so step 1. We're going to set the equations equal to each other. So that means I am going to write x squared minus 3x minus 10 equals negative 2x plus 2. That's your first step. Since they both equal y, they must equal each other. So set them equal to each other. What kind of equation do I have now?
One you can solve.
I do have one I can solve. Is it linear, quadratic, or exponential?
Quadratic.
It's got an x squared in it, which makes it quadratic. So if I'm thinking back to chapters 8 and 9 where we solved quadratics, what does my equation have to equal before I can solve it? 0. Okay, so that is going to be step 2. Since it's quadratic, we need to rewrite the equation so it will equal 0. That means I need to move this negative 2x by adding 2x to both sides. And I need to move this plus 2 by subtracting 2 from both sides. And that will get me x squared. Negative 3 plus 2 is negative 1x. Negative 10 minus 2 is negative 12 equals 0. So now I have my equation equal to 0. The next step in solving it, well, we learned a couple different methods of solving quadratics. We could use a quadratic formula. We can try factoring it and using the 0 product property. We can complete the square and then undo it to solve. So I am going to solve this using any of the 3 methods that you've learned so far. The one that I'm going to choose to do for this, though, is factoring. So I'm going to factor it and then use the 0 product property. So if I'm factoring, that means I need to have an area model and a diamond. In my area model, the x squared is going to be what goes in the bottom left, and the negative 12 goes on the diagonal with it. And then I multiply them to get the top of my diamond, and the x term is the bottom of my diamond. So now I'm looking for 2 numbers that multiply to negative 12, so I've got a positive and a negative, and that add to negative 1. So what 2 numbers? 3 and 4. Okay, cool. Which one should be negative, the 3 or the 4? The 4 should be negative, so that when I do 4 minus 3, or sorry, negative 4 plus 3 gives me negative 1. Okay, so I've got negative 4x, positive 3x, and then I put those into my area model, and then I can work the outside to get my factored form. X plus 3 times x minus 4 equals 0. So for this step, in case you want to write down what we're doing here, we are factoring and using the 0 product property. Okay, so this is the factoring part. Now the 0 product property part is saying, okay, x plus 3 might equal 0, or x minus 4 might equal 0. So to solve this, I would subtract 3 from both sides, and I would get x equals negative 3. So there's one of my x's. Add 4 to both sides to get rid of the negative 4, and I would get x equals 4. So there's my other x. If I'm looking for a point of intersection, am I done? No, because a point has to have an x and a y. I found my x's. So now I need to find my y's. So your fourth step, plug each x into either original equation to get your y. Okay, my original equations, one of them was a quadratic and one of them was a line. Which is going to be the easier one to plug into? The line. Okay, so my line was negative 2x plus 2. So that means that down here, I can plug negative 3 in for x into negative 2x plus 2 to get my y. So that's the first one I'm going to do. So where x equals negative 3, I'm going to say y equals negative 2 times negative 3 plus 2, because my equation was negative 2x plus 2. Negative 2 times 3 is 6, plus 2 is 8. So the answer, or the y that goes with negative 3 is 8. So my point would be negative 3 comma 8. Now I'm going to do the exact same thing for when x is 4. I'm going to plug it into y equals negative 2x plus 2. Oops, but I'm plugging 4 in. I don't want x. So negative 2 times 4 plus 2. That gives me negative 8 plus 2, or negative 6.
You plug it into any one of those slices?
You can plug it into either one of the original equations. This one is less work because you only have to plug it into the one spot and there's no squaring or anything involved. So if you have the choice between plugging it into a linear equation and a quadratic, the linear will be easier. But it has to work for either one of them. So both of them will get you to the right answer. All right, so the points of intersection are going to be negative 3, 8, and 4, negative 6. So finding them algebraically is just solving the system of those two equations.